All right, so for this first one, we're going to draw a graph to represent these parametric equations. So I'm going to start by making a table for my parameter t and for x and for y. So we'll do them one at a time, and we want t to go from -2 to +2. So plugging these numbers in for t for our x equation is going to give us -4, -2, 0 to 4. Plugging these values in for our y equation, that's going to be what, -3, and then 0, 1, 0, -3. Now, when you go to plot it, you're not going to plot the t values. You're just going to plot x and y. T is just your parameter. This is your x and y axis. So -4, -3. My paper didn't print very well, so kind of imagining where the grid lines are here. -2, 0, 0, 1, 2, 0, 4, -3. And so we start here and go in this direction. And so showing the orientation is just your little arrow showing which direction it's going. For part B, we're going to write the corresponding rectangular equation by eliminating the parameters. So we just want x and y. We don't want t in there. And then we're going to state the domain, which we can kind of see from looking at this. So what I would do is get t by itself in the x equation. That's an easier one to deal with than the y equation. Just pick the one that's easier. We're just going to divide the 2 over and say that t is 1/2 x. And then I'm going to take that 1/2 x and plug it in for t in the other equation. So it is going to look like this. And then to clean that up, our negative is going to stay, and we're just going to square everything that's in there. So it'll be 1/4 x squared and then +1. So that is your answer. And then your domain is that x goes from -4 to +4. And if you prefer interval notation, you can write it like this. So those mean the same thing. Whatever preference is yours. Neither one is better or worse than the other. All right, write parametric equations for x and y for this rectangular equation where t equals 1/4 x. Okay, so your x equation is going to be the easiest one to do. Just get x by itself here. We're just going to multiply over the 4. So x equals 4t. That's our x equation. And then I'm just going to take that and plug it in for x in my other equation. So we're going to have 2 times 4t squared plus 6 times 4t. So you get x in terms of t and y in terms of t. And then just to clean this up, 4 squared is 16. Double that is 32. The t is also squared. And then plus 24t. So it's just doing the algebra to clean that up a little bit there. All right, find dy dx for these two parametric equations. So we're going to do dy dt over dx dt. So dy dt, e is its own derivative. So it's going to be 2e to the 3t, but there is a chain rule. Chain on the derivative of 3t, which just gives you 3. And then down here, another chain rule, derivative of sine is cosine, and I'm going to write that as 1/2 t instead of t over 2. I strongly suggest that. It always throws everybody off when it looks like that. If you have a t over 2, write it as 1/2 t, or if you have a t over 3, write it as 1/3 t. And then you can see that your chain rule is going to be to chain on that 1/2. To clean that up a little bit, I would multiply both the numerator and the denominator by 2. So that you can not have a fraction inside of a fraction. Up here, we've got 2 times 3 is 6, times 2 is 12, e to the power 3t, and then over cosine of 1/2 t. Because if you're doing multiple choice, they're not going to leave it like this with that fraction in there. They're going to clean it up. So it's good to know how to do the algebra and make your answer look a little nicer. All right, for this one, we're going to do a second derivative. So first, we're going to do the first derivative. So same thing we just did in the previous problem. I'll move this over here so it's a little less washed out. So we're going to do dy dt over dx dt. That's going to be 12t squared minus 5 over just 3. Now, what I would suggest, because I have to do a derivative of this, I would take both of these and just divide them by 3. 12 divides by 3 nicely, so it's going to be 4t squared. And then it would be minus 5/3, but I'm not super worried about that because that's a constant. It's going to go away when we do our second derivative anyhow. So now we're going to do the derivative of what we just did and then over dx dt again. If you're thinking like an acceleration, that's the part that makes it like per second per second. So this is going to be 16t, and then like I was saying, this part goes away, so I wasn't so worried about that anyway. And then over dx dt again, which is just 3. So that's your final answer there. All right, graph of these parametric equations has what slope? All right, well, it's going to be dy dt over dx dt. So that would be 7 over negative 3. All right, that's it for that one. I'm going to throw a real simple one on there. All right, for what values of t does this curve with these parametric equations have a vertical tangent line? That means dx dt equals 0. If it's horizontal tangent line, it would be dy dt equals 0. And if you think of your dy dt being the numerator and your dx dt being the denominator, that's how that matches up. We want a 0 denominator for an undefined slope, vertical line. So I actually don't even need this at all. I'm going to take this derivative. That's going to be 3t squared minus 4t plus 1, set it equal to 0. What's honestly tougher about this problem is the algebra. You have to be able to factor this. So welcome back to Algebra 2. We're going to split up 3t squared. That's going to split 3t and 1t. And if you multiply those, you get 3t squared. And then we're going to split up 1, which is just 1 times 1. And I'm going to end up erasing these, but just to show you like what's happening here. If you multiply the outsides together, you get 3t times 1. If you multiply the insides, you get 1t, 1 times t. And we want a negative 4 in the middle. So they're going to need to both be negative, -1 and -3 to get -4. The other way you can check that your signs are correct, if you do -1 times -1, you get +1. Those negatives are going to cancel. And so we're going to actually get 2 answers for this. If you set this factor equal to 0, you're going to get 1/3. And if you set this factor equal to 0, you're going to get 1. Now, neither of these came out negative, but if they had, you still get to keep them. T isn't necessarily time. If you're doing a story problem, which we're going to get to later this unit, then yes, T can mean time, but not necessarily. T is just the parameter that both the x and the y equations are in terms of. And if you think about this graph, we plugged in negative values of t. So, that's literally just your parameter. Unless you're doing a story problem or you're told that it's time in seconds or something like that, if you did get a negative answer, you get to keep it. You don't have to throw out a negative answer in this case. All right, here's our 2 parametric equations. We want the equation of the tangent line. So you need a point and you need a slope. They just handed us our point. Just need to go after our slope. Now, I need to know at what t value all of this is happening. So you can pick the one that's easier for you. You can either set the x equation equal to the -1/8 or the y equation equal to the 16. In this case, I think it's honestly easier to use the x one because it really sort of matches up nicely. You have a -1 and a -1. You just need this denominator to come out to be 8. And that would happen when t is 2. 2 cubed gives you 8. When you have an even power, things get complicated because then you get pluses and minuses and things. So I honestly think this one was a little bit easier to use, but you can use either one. All right, so we need our slope. That comes from our derivative. So we're going to find dy dx. So dy dt over dx dt. That's going to be 16t over. Now I'm going to do a little margin problem off to the side on this one because I don't want this work to clutter up the area I'm working in here. So I'm going to just come off to the side. This is really -1t to the -3rd since I have that t cubed in the denominator. And when I do that derivative, negatives are going to cancel. When you subtract 1, it becomes more negative. And so when I write it over here where I want to put my answer, it's going to be 3 over t to the 4th. This is kind of up to you, but I am going to take a step and clean this up a little just because I'm going to have to plug 2 in. So I'm going to multiply in order to cancel this out so I don't have a fraction inside of a fraction. The step is kind of optional. You can just go ahead and plug in 2 if you want, but I think this is going to make it look a little nicer. This will be 16t to the 5th over 3. And to get our slope, we're going to plug in 2. So 2 to the 5th is 32. So we're going to have... I thought I made it something you could do without a calculator. Oh, I can't multiply. 4 times 2 is 8. Not 16. I squared it. I am so sorry. It happens. All right, so that'll be 32 times 8, which is 256. There we go. Over 3. And that doesn't divide, so I'm going to leave it like that. And then we're going to write our answer. Y minus 16 equals 256 thirds, parentheses, x plus 1/8. And that's our final answer. All right, and then last one, set up, but do not evaluate the integral for the length of the path. This is arc length. So we're going to have our integral from 0 to 1, great big square root dt at the end. We're going to leave it blank to start out with. And in here goes dx dt and dy dt. So if we multiply the 10 down, a fifth times 10 would be 2, and then t to the 9th. And then if you multiply this 2 down, you get 2/4, which would just be 1/2 just t. This one is multiple choice on your quiz. I can tell you the choices will not look like that. So you are going to have to do one more step to simplify it, but it's just squaring. 2 squared is 4. This will be t to the 18th. Half squared is a 4th, and then t squared. So that is what your final answer will look like.